Welcome to my first mathematics problem solving video. Today, we're going to focus on mathematics, more specifically calculus, because we have to try some questions in order to really understand how we approach these kind of questions because learning a concept requires a different skill from actually solving it. And therefore, I want to just go through some of the questions, more specifically mathematical questions, and more specifically calculus. And I have two questions ready for you. One is from the standard level, and one is from the higher level, IB mathematics. So, looking at the standard level mathematic question, well, they actually provide us a function in this question, which is fx equals e to the power of x squared minus 2x minus 1.5. Now, the question is asking us to find the derivative of fx. What is the derivative of fx? So just from looking at this equation, you may realize something that's a little off. It's not used to the kind of question that you're used to, which is like, for example, x squared minus 2x. Those are really easy derivatives you can solve. But this is a little different because you have e and then to the power of x squared minus 2x minus 1.5. You may wonder, how am I going to approach this question? So the fact that you actually thought this was not a normal question is a good first step because when you realize that it's not a normal kind of function, you have to look at the rules that you know. Those are in the formula booklets. The three main ones I would think of is the chain rule, product rule, or the quotient rule. Now, in this case, we use something called a chain rule. And we use chain rule because this is called a composite function. The function they give us is called a composite function. Now, what is a composite function? Well, I like to think of composite function as that there's a base function, and in that base function, there's another function that just goes into it. So, what do I mean by that? Well, from this equation, we can kind of think of it in two parts. There's e to the power of x, and inside that x, we have x squared minus 2x minus 1.5. You can kind of think of it as this function is kind of going into the e to the power of x. So what do I do with that information? Well, let's just look at what the chain rule is. Chain rule tells us that dy over dx is dy over du times du over dx. Now, where do I get those y's and u's? Well, it's you have to think of it as this. We have to simplify this equation, e to the power of x squared minus 2x minus 1.5. An easier way is to say that x squared minus 2x minus 1.5 is equal to u. Therefore, this equation becomes e to the power of u equals y. Let's just make it y instead of fx, just to make it easier. Now, how does this help us? Well, obviously it helps us because y is the function that we have, and to find dy over dx, which is the derivative of the function y, or the equation y, first what we have to do is find the derivative of the function y in terms of u. So what is that function y in terms of u? Well, this is the function we just made right here, where y is equal to e to the power of u, where u is equal to x squared minus 2x minus 1.5. So we first have to find the derivative of y, which is just e to the power of u, because when you have a function of e to the power of u, the derivative of that is just e to the power of u. Now, we find the derivative of u in terms of x. So where do we have that equation? Well, we have this equation here because we have u in terms of x, right? So the derivative of x squared minus 2x minus 1.5, as you may know, is simply just 2x minus 2. Okay, we're not done here yet because we have to convert this u back into what we originally had, which is just simply x squared minus 2x minus 1.5. Multiply that by 2x minus 2, which we can actually simplify it further by saying 2 to the power of x minus 1, 2 times x to the minus x minus 1, and e to the power of x squared minus 2x minus 1.5. This is actually just the answer to this question. So what we get from this equation, this kind of question, is the fact that when you realize something is off with the function, you first have to refer to the rules, the three rules I mentioned. And when it's specifically a function that has a function inside it, we refer to the chain rule. And the chain rule is given in the function, the formula booklet, but it is this. And what we do with that is first we split the given function we split this into 2. So we did that into e to the power of x, and inside the e to the power of x goes x squared minus 2x minus 1.5. So we kind of split this into two equations, this equation and this equation right here. And what we did is we made one of the equations that goes inside equal to u. So we have a simplified version of e to the power of u equals y. Find it, use the chain rule, and voila, we get the answer. Now it's a little complicated, so that's why you have to keep on practicing. Just remember these steps I said, and you should be able to, start getting the hang of it. So practice makes perfect. This is just one example, just to kind of help you with the thought process. Now, this question actually has a second part, which is that we're given the function y equals fx over x minus 1, where fx is the same from the previous question. Oh, sorry. Let me just write that again. So let's just plug in the previous equation, so which is e to the power of x squared minus 2x minus 1.5 over x minus 1. Now, what we're also given is that it has a local minimum at x equals a, where a is bigger than 1. Now, what we have to find is the value of a, but what do we do from here? Well, remember this. To find a local minimum, you have to always find the derivative of the function, make that function, the derivative of the function, equal to 0, and solve for x. So what we have to do is we have to find the derivative of y, and we have to make this equal to 0. And then we should be able to find the value for x, which is what it's going to be for a. So let me just delete this for the sake of space. So first we have to differentiate this function right here. How do we do that? Well, again, it does not look like the ordinary question that you're used to, so you might ask yourself, what do I do from here? And to answer that question, remember, refer to the 3 rules we have, and we have to identify which rule to use. In this case, we're going to use something called a quotient rule. Why? Because quotient rule is actually y equals u over v. Given that it's y equals u over v, then the quotient rule tells us that the derivative of y in respect to x is simply, well, it's not very simple actually, v times du over dx minus u times dv over dx all over v squared. Now that was a handful, but don't worry, this is in the formula booklet, so it's always going to be there when you need it. And what it's basically telling us is to identify the numerator, the denominator, and use the quotient rule to find the dy over dx. So in this case, the numerator is going to be what u is. So in this case, the top one is going to be u, and the bottom one is going to be v. Sorry, it's very, very messy, but hope you guys really understand what's happening here. So let's just try to solve for dy over dx. I really need to work on my handwriting actually. So v is x minus 1, so we just simply write x minus 1. We multiply that by du over dx. Du over dx means the derivative of the numerator. Actually, we did this from the previous question, which is just 2x minus 2 times e to the power of x squared minus 2x minus 1.5. And we subtract that and we multiply u. So u is just simply going to be e to the power of x squared minus 2x minus 1.5. And the derivative of v in respect to x, which is derivative of x minus 1, which is simply just 1. Now we divide this over v squared, which is x minus 1 squared. Cool. Now what do we do here? We want to simplify this equation just so we can find what x is when this is equal to 0. Remember, because to find the local minimum, we have to find the value of x when the whole derivative is equal to 0. So we can actually find the common factor of e to the power of x squared minus 2x minus 1.5 here. And the common factor is just x minus 1, 2x minus 2 on the left hand side. And we're subtracting that by the common factor, which is going to be 1 here. And all of this divided by x minus 1 squared. Again, this is still equal to 0. Now, why did that actually help us? Actually, we can further simplify this. Minus 1.5, sorry, here, sorry. Now remember, we can actually just expand these two functions. It becomes x squared minus 4x plus 2, and then minus 1, which just basically means it's simply just gonna be plus 1 all over x minus 1 squared equals 0. Well, remember this. We have to make this fraction equal to 0. That means the numerator has to become 0. And there's two kind of factors, e to the power of x squared minus 2x minus 1.5 times x squared minus 4x plus 1. Now, if you know this rule, then you'll know, but e to the power of x can never be 0. It's just not possible. Therefore, we have to consider when x squared minus 4x plus 1 equals 0. Now, what we're gonna have to use is the this quadratic formula. Sorry, I just forgot the name. Negative b plus minus the square root of b squared minus 4ac all over 2a. There's different ways of remembering this. I just remembered it by like a kind of a song. So when I'm not gonna actually do this. It's really simple. B is again this factor, this number negative 4 here. A again is just the 1 here. This is the invisible 1, and C is just 1. And we just plug these into the quadratic formula, and we should actually get x equals we should get x equals 1 plus minus the square root of 1 over 2. So we have two actual answers here, right? If you think about it, because we have x equals 1 plus square root 1 over 2, or x equals 1 minus square root 1 over 2. But remember, a has to be bigger than 1. Therefore, that means x has to be 1 plus square root 1 over 2, because 1 minus square root 1 over 2 will be less than 1. There you go. This is the answer for this question. Again, sorry guys, I'm not the best at teaching, but hopefully you guys understood something from there. Again, you can always go back to the video, kind of solve it while I'm saying it, so you understand a bit more. Now let's just go to the HO question. So this is we're given that limit of x when it reaches 0 is tan x over x plus x squared. So when x tends to 0, which is the limit when x reaches to 0 of tan x over x plus x squared, what is the limit of that? Well, that's what we're trying to find, right? So basically, what we always have to do with this question is firstly just plug in 0 into this equation. Tan 0 over 0 plus 0 squared is simply just 0 over 0. Now, when you have a function, when you have a limit that's either 0 over 0 or infinity over infinity, then we use something called the L'Hopital's rule. The L'Hopital rule basically tells us that when a limit x0 of fx equals limit x over 0 of gx, when they're both equal to 0, given that fx over gx, right, limit x tends to 0, when we're given this function right here, and when the numerator and denominator is both 0, then what we have to do is what we can do is, this is the given rule, fx over gx. If this is equal to 0 over 0 or infinity over infinity, then we can actually find the derivatives of the numerator and the denominator. Oopsies. We can find that it's going to be the same answer nonetheless. Well, not the same answer as in like it's going to give us the correct answer. So the derivative of tan over x is simply just secant squared x over the derivative of x squared plus x squared is simply just going to be 2x plus 1. And when we plug in the 0 again, secant squared x is just going to be 1, because 1 over cosine squared x is what secant squared x is. Cosine x is 1, square that is still 1, 1 over 1 is 1. And 2x plus 1, when you put 0, it just becomes 1. So the answer is 1. So this is a longer video than expected, so I'll just end it right here. I'm going to keep on doing this kind of questions. Again, I'm not the best at explaining. If there's any questions, just always ask in the comment section. This is, again, the first time doing this, so I'm not the best at it. Thank you guys for watching.